Hello and welcome back to the Dragonfly Daily. I am your host, Mike. Please look for me on Twitter. We'll have announcements of when these videos hit YouTube. But contact me and we can get you registered so you can attend these live. So thank you for attending. This is lesson 12. We will do resampling, converting, inverting, clipping, and cropping. If you are watching on YouTube right now, hit that subscribe button right now so that we know you want continued content on how to use Dragonfly. So this is lesson 12. We will be doing these new image processing operations that we haven't covered before. These are a little bit esoteric. We're actually now diving in a little bit into sort of classical image processing discussion. I don't want to get too technical. This isn't really an image processing course, although we could provide one. That would be quite interesting. But we're going to show how to use some simple operations that every image processing tool should have. We're going to show you how you can do them in Dragonfly 4.1. And as always, since lesson 6, we are using the customization of Dragonfly discussed in lesson 6. The agenda for today, we will be first looking at convert, and this is how you convert a data type image. So sometimes you have images that are type byte, where you have an 8-bit image that may have intensities between 0 and 255, or you may have type unsigned short, which is sometimes called a 16-bit short image, where the intensities may value between 0 and 65,535, or you may have float or other data types. So convert is how you're able to convert an image from one data type to another. Very, very simple, quite uninteresting, but sometimes you need it, and so we'll show you where you can find it. We'll also look at invert, which is, in this case, we're going to talk about two different definitions of invert. We'll talk about inverting the intensity of the images, but we'll also talk about swapping axes or changing the orientation of the image in your workspace. Then we will discuss resampling. Resampling is really about sort of changing the scale or the pixel size of your image. Your magnitude will stay the same. So if your mitochondria is 3 microns across, it'll still be 3 microns across, but maybe instead of 6 pixels wide, it would be 12 pixels wide or 3 pixels wide. So it's changing the number of pixels per unit space. That's the pixel size. We'll talk about when interpolation will occur or when it won't. Then we'll talk about the two different ways you can resample, either from the resample panel or from the resample geometry menu item, which can induce rotation. The latter can. So hopefully we can cover that. Then we'll talk about clipping and cropping. We may actually do these in a different order. And then I will try and enforce an idea that when you use extract structured grid, which feels like a crop operation, but when you use extract structured grid, as we saw in Introduction to Shapes in, I believe, what was lesson 7, you'll see that that forces a resample, which can have consequences to how your data are mathematically interpreted or maybe even visually interpreted on a very, very small scale. So that's what we're going to cover today. So let's move over to Dragonfly and dive right in. The data I'm using today, we can post these all on the Dragonfly landing page where you can go to the sample data sets and then find these posted later today. I intend to post them. The data sets that we're working with, we're going to work with 3 different data sets. The first data set we're looking at, and all these are just synthetic data sets. They are phantoms to illustrate concepts. So the first data set is this thing called crosshairs with index. If I go to a full screen view, you can see that in the z-axis and xy view, when I'm on slice 51, it says 51. And as I scroll through the data, I have the crosshairs and the position of this square changes. If you let's put it in track state. If you move these slices, for example, you can see they're quite uninteresting. Really, they're only meant to be interpreted from the XY view. So this data, this one called crosshairs, this was generated by my colleague Mathieu Gendron back in the office in Montreal. Thank you, Mathieu, for this. The second data set we'll look at, we're going to look at 2 versions of a Shep-Logan phantom in 3D. So this is a construct that's often used by people that are interested in reconstruction, 3D reconstruction from medical imaging. You'll see this in all the medical imaging reconstruction textbooks or any volumetric image reconstruction textbook. You'll see the Shep-Logan phantom. This is a 3D Shep-Logan phantom. In this case, if you want to read about this particular Shep-Logan phantom, it's specified in this paper. This specification says, okay, you should have an ellipse here and an ellipse here, and then at different slices, you'll have different circles and ellipses, and they'll have different intensities. So this paper specifies what the definition of the phantom should be, and this is an implementation of that phantom, again, done by Mathieu. We have 2 different versions of this. We'll talk about why in a few minutes. And then the last data set is an array of plates. And so this is used for certain test cases that we do. So you'll see in the middle of the field of view, I'll double click to go full screen, you have some thick plates and some thin plates, and then on the edge you have some thin plates. And if you look at it from the side, from this view, you'll see you have some plates that are long and thin, some plates that are thin and thin in both axes. So we'll see why we are going to use this in a few minutes. All right, let's start with the crosshairs with index. Now, in this data set, you'll see that I have some intensities. Let's look at the probe function. So what I mean, if I look at probe, so you can always expand probe by clicking on it, click the probe button. If I click in here in this square in the middle, you'll see it has an intensity of 159. If I click in any of the black pixels, I have an intensity of 0. These pixels right here, 158. These pixels right here, 231. We have different intensity pixels. We can always change the on-screen brightness or contrast with the window leveling tools as always. Now, the first lesson here is the convert, I guess is what I'm going to do first. So if I right click on the image, you'll see a number of menu items that appear over here. And in 4.1, you can look in the modify and transform submenu and you'll find convert. If I click convert, you'll get this tool. This allows me to convert my current data set, which happens to be unsigned byte or char or 8-bit. This is, if you don't understand this, you'll have to go through some image processing background to understand it, but it's not that important if you never understand this. It's not going to block your interpretation of images. This is for more advanced functionality where you need to get your data into a particular data type. Anytime you click on an image, you will see its properties here, and this will tell you that it's unsigned byte. Now, if we go back to the Dataset Tools Dataset Cropper, you'll see that I can convert it to 16-bit or unsigned integer 32-bit or float integer. I can also normalize the intensity. So I could take this intensity range that currently goes from 0 to 231 and I could scale it to 0 to 1.1 in float. Or if it were unsigned short, I could scale it from 0 to 65,535. So this would create a new data set. And if we now turn that image on, it's going to look the same, but now it's going to be scaled. If I select it, you'll see it's scaled on a different scale. And so if I do the probe here, you can see that my initial image still has an intensity of 231, but the converted image has 65,000. If I go in here, initial image 121, converted image 45,000. So this is rescaling the intensities when you have that checkbox normalize turned on. So I don't want to get into this. This is if you need to convert from float to char, or from char means the same as byte, or from byte to float or to U short, this exists and this is where you can find it. And that's really all I want to say about crosshairs. I'm sorry, about convert today. Now I'm going to select the converted data set and remove it from my workspace. Now, the next thing I want to mention is invert. If I right click and I go back to that same modify and transform submenu, one of the menu items here is invert. Now, invert means basically two different things, or maybe even three different things in this context. So the first and maybe most obvious is invert the values or invert the intensity. If I click apply, I have now created a new data set, and if we visualize it, you can see that all the intensities are inverted. So these values outside that were 0, they are now 231. These values that were 231, they're now 0. So the intensities have been inverted or flipped. You may use that from time to time. We're not going to get really into any details today on when you will use these. This lesson is more for completeness. Some of you who have been doing image processing for 5 or 10 years know that you need these occasionally in your workflow, and so we're really sort of filling in the gaps and showing where you can access these. So this lesson is very practical for image processing experts, not quite as practical for the new users, certainly not as practical yet as yesterday's lesson on image filtering, where you can see the obvious applications. So maybe we can start a forum post or a follow-up lesson on when you're going to use some of these tools. But again, these are needed for completeness in any image processing application. So I have inverted the intensity. I'm going to remove that image. I'm going to draw your attention to the create new data set. If I had not checked that and I hit apply, it will actually invert the image in place. So my image itself has been inverted instead of creating a new inverted copy. And you'll see that on a few different image processing tools in Dragonfly. I'm going to invert it once again. So that's the first meaning of invert, is to flip the intensities. Now you can also flip the we can do what's basically a mirror flip about a particular axis. So if we come over here and we look at this pixel right here, we can see that in my crosshairs with index, it has a voxel coordinate of x equals 3 or x equals 2. And over here on this side of the image, like let's look at these pixels right here. These pixels in the one, they have an x coordinate of 236. Sometimes you might need to do a mirror flip, and I actually will be able to explain why in just a minute. Well, if I say I wish to flip about, I think this is inverting the x-axis, and I hit apply. Now, when I come over here, these pixels, they have now switched over to x equals 22. Recall they were over here at x equals 236. So we've done a mirror flip. Now, you might have an image, you might be doing a correlative image study where you've collected one data on the SEM and another data on the light microscope, and maybe the light microscope has a different convention for recording the images, and it may have the axes reversed. And if you bring both of them into Dragonfly and one of the axes is flipped with the other, you'll never be able to align them until you're able to do an axis flip. So it's like aligning two achiral molecules or stereoisomers. There's no alignment that can be done until you be able to apply some sort of transform or flip. So you can flip the x-axis, flip the y-axis, flip the z-axis as well. The last option here, this is a bit esoteric, but you can do an axis swap. So this axis where you see here, this pixel right here has a y of 254, and up here it has a y of 6 or 7. This is the y-axis going this way from away from the 51 to towards the 51. You could remap that y-axis onto the x-axis, for example. This, again, can be useful when you're trying to register data sets from different image sources. If I wanted to flip the x and y axes, I could choose the y-x, whereas y-x-z transform. Sorry, I want y-x-z, and here it is. So if I apply this, then now these pixels that were on the y-axis are now on the x-axis. So I'm going to tell you, you can use Dragonfly for 10 years and never need this function. For those of you that do need it, you probably only need it once every year or two. This is a very esoteric function, but it is needed for completeness in any image processing toolkit. Now, if I do this again, it's going to again swap the x and y axes, so they're going to be back where they were. All right, that's everything I'm going to show you with the invert. I'm going to click close. I'm going to go back, and that's everything I needed on the invert. So we have done convert. We have done invert. Now I think we're going to move on to crop. So I want to look at this image for a second, and we will discuss clip and crop and resample. Yeah, all right. So if we look at this particular image, I want to point out some details because we're going to introduce some interpolation with resampling at some point in this lesson, and you're going to need to understand when that helps you or when that hurts you or what the trade-offs are when you introduce resampling or when you introduce interpolation because of your resampling operation. Now, I have two different versions of this Shep-Logan Phantom. This Shep-Logan Phantom has something turned on called anti-aliasing. Can't get into that without a 20 or 30 minute lecture in image processing, but I'm going to show you what it means in a brief view. So I'm going to go back to the track mode. I'm going to do a middle mouse to drag. Now, if you look at these pixels, you can see if I were to do a probe, once again, you could see that over here they have an intensity of 150. Over here they have intensity of 0. Here it's 250. So 150, 250, 0. But you'll also notice that the pixels on the interface are somewhere, in this case, in between 250 and 150. So you see this pixel is 232, and this pixel is 158, and this pixel is 148. It's weird that that's 148 instead of 150. But so you have this gradual transition. And this is what most scientific images look like, even if you've got two true materials that have true intensity or density. The physics of imaging will also often introduce partial volume effects or a point spread function that blurs out and you don't get a step or crossover. And I'll only show you what I mean. This is an image of the Phantom without any anti-aliasing, and these pixels are 0, these pixels are 250, and these pixels are 150, and you see there's no interface pixels. Scientific images never look like this. I mean, there are some, if you're doing an SEM with extremely high resolution, you might not have those partial volume effects that you have in CT. So you could sometimes get images. Most scientific images are going to look like this. Okay, now I needed to set that up because I want you to be able to see some differences when we do some cropping and clipping. All right, so let's start with this image. That is the Shep Logan Phantom without anti-aliasing. Now, I told you, switching back to track mode, and I'm going to double click. I told you I was going to talk about clipping and cropping. So the first thing I'm going to tell you about is where to find the clip box. If I select this image, at the very bottom of its property panel is clip. If I turn this on, we now see a clip box. It's very much like the visual box that we saw here. However, I cannot rotate the box and I cannot move it away from this image channel. This clip box, it is bound to this image. Now, I can drag the face of the clip box. I can drag any of the faces of the clip box in 2D or 3D. So here I'm doing it in 2D, here I'm doing it in 3D. And you can see immediately the effect. I'm able to see sort of inside the clip box. Now, as long as the clip box is showing and it's not locked, whenever I mouse over, the face of the box will highlight. If I mouse over here, it slightly changes color. If I were to come over here and expand this panel, you will see there is an option to lock the clip box. So now I can look at the clip box and it is locked. It's no longer going to respond. So that's what happens when you turn on lock or unlock. There's also this behavior of outside. So you could do sort of an invert clip. So now you're clipping only things that are inside the clip box or outside the clip box. I'm not sure what the nomenclature is for clipping, but you can see the difference between checking the outside and unchecking the outside. So point number one, clipping, which is what we see right now, is a visual operation that happens in the 3D view. It does not change your data. As you can see here, all of the data is still here. All it does is change what is shown on screen in the 3D view. So we can see the data. It can be a useful way of slicing into the data. Let's turn this back on. So if I want to crop and look at the inside of the data, it's a very useful tool. That is clipping. Now, we sometimes call this the clip box, and we also call it the crop box. Now, let me tell you why. I'm going to, So I could turn off the clip box. Well, let's just say I had left the clip box right here, and then I turned it off. At any point, I can right-click on the image channel, and I can go back to that Modify and Transform submenu, and I can choose Crop. It will normally, let's see, did I choose the right one? That's without anti-aliasing. Normally, it turns on the visibility of the clip box. I'll turn it on for myself. Now, what this does is this allows me to create a new image channel that is what is only inside the box. So if I know I want only pixels 1 to, let's say, 400 in the x-axis, I could type it in directly, or I can interactively change it. So you can change the x dimension and the y and the z dimension. And then whenever you hit apply and hit close, now you'll see I have another data set. Now if we go, and this is the data set I've been working on, but if I turn on this data set and then I hide the source data set, oops, hide the source data set, you can see I have now cropped. So point number one, clipping is a visual operation that affects what you see in 3D. Point number two, cropping actually is to change or create a new data set where you have gotten rid of everything outside of the bounds of the box. Now, this may look a lot like when we used the visual box. However, there are some important differences. Now, if you I'll double click and I'll zoom in, and this looks exactly like the source image. So if I turn the source image back on, and then I hide this image, you can't see the difference. It has made, here, let's look right here. All right, so the underlying image is down here. If I turn it back on, we can see, and you can see no difference at the top when I turn this on or off. So this has made a sub-volume. That's what a crop does. It makes a sub-volume. And you make the sub-volume on an integral number of pixels. So I could say I only want pixels 0 through 400 in the x-axis, but I can't say I want pixels 10.5 to 410.5. I can only use an integral pixel index. Now, that is very different from using the visual box. So let me show you what I mean. I'm going to get rid of this, and I'm going to take my Shep Logan, and I'm going to ask for a new visual box, turn on the visibility. Now, suppose I were to do a crop, and I were going to do and use the extract structure grid feature we saw once before. And I set up my box, and I put it wherever I want. And let's say I want to extract out this subvolume. Now, if I then come over here and I right click and I say extract structured grid, and I choose Shep Logan without anti-aliasing, that's the data set we're looking at right now, and I click OK, now I have extracted, and let's look at it. So I'm going to zoom in, and what you see is that these pixels now have a different orientation. So the pixel orientation is parallel to my box. If we look at the original data set, so let's turn on Shep Logan without anti-aliasing. These pixels are parallel to that initial box. These pixels in the subvolume from the extract structure grid are parallel to that box. This is effectively applying a rotation, which introduces a resampling. And so now you see that instead of going from 0 to 250 to 150, we have to have some pixels on the interface. This is absolutely required. There's no way to get the source geometry the same, that is, maintain this shape on this new pixel grid without introducing some sort of interpolation. So here, if you zoom out, this is fine for this data set. We still have all of the shape information we care about. We still have the intensity right here, but the interface pixels are different. Now I'm going to show you a case where that might be disruptive. So what I will do is I will look now at this array of plates data set. So we have this data set. If I were to use a shape and extract something out over here, so let's turn on a shape. Let's get the visual box going. And let's say I want, for some reason, and we saw this with a cell phone example in lesson 7, you may want to get a box that's just right for the size of your shape. Now, it doesn't match the size of this shape, but this is just an example. If I were to do this and use the extract structured grid and tell it I want to extract it on Shep Logan without anti-aliasing, then here's what we have. Let's try it again. What did I do wrong? All right, I do have, I deleted the box. Did I delete the box? Sorry. Let's turn on the box again. Create a box. Turn on the visibility. Set the box so that I end up doing some, I can extract structured grid. And I don't know why I chose Shep Logan. I want to extract on array of plates. That was my mistake. So extract structured grid. Do it on array of plates. Click OK. Now, let's look at this data set. So let's hide the underlying data set. You see this has this intensity proper, this intensity. It had to introduce some fuzziness here. Now, when you zoom in over here, you might be able to tell that this was a line 1 pixel thick in the source data set. So we can look at array of plates. You can see this is how it's resampled. But if you were trying to interpret these pixels and trying to reach the conclusion that it's 1 white pixel followed by 1 black pixel followed by 1 white pixel, you really don't have enough information to make a high confidence evaluation there. So the shape information is preserved, but fine details of features that are single pixel thick, you're going to be in very rough shape whenever you introduce interpolation. And so it's very important to know that when you extract structured grid, you can get a very nice oblique crop effect, but you are having to introduce resampling. So that was the whole point of that discussion. Now, I'm going to get rid of this. And I'm going to get rid of this. I did tell you there is a way to do a resample. So apart from doing the extract structured grid. So suppose I right click on the visible image channel and I go to modify and transform submenu once again. I can choose sample. When I come over here, it's telling me that this data set has 419 voxels. If you wanted to resample this so that it was 1,000 pixels wide, you can resample it. If you wanted to change the sampling from 5,000 microns per pixel and you wanted it to be twice the resolution, so you wanted twice the pixel density, you could set it from 5,000 microns per pixel to 2,500 microns per pixel. Or for that matter, you could just introduce an upsampling or a downsampling. So you could upsample by 2 and it goes from 5,000 microns per pixel to 2,500 microns per pixel. you can also downsample by a factor. So if I downsampled this by a factor, I would no longer have the resolution to see any of these features. So it could be really disruptive to the image. Of course, if you downsample the image, you're not going to have the sampling you need to see high resolution features. So if I choose downsampling and I use this cubic interpolation kernel, I haven't even tried this. Let's try downsampling by a factor of 2 and hit apply. And let's look and see what that data set looks like. As you can see, I've lost the fine details. So this is what it's supposed to look like, and this is what the downsampling looks like. So I can't even see any of those features that were 1 pixel thick. So that is, you have the ability to do resampling in Dragonfly, and there are 3 different ways. We can use it with the extract structured grid. We can use it with the menu item we just looked at. We're going to see a third item in a minute. So there are 3 different ways to do resampling. But when you do resampling, if there's any rotation or any shift in the origin of the box, then you could possibly introduce interpolation. So that's a trade-off. And like I said, we could get into a whole lecture on what interpolation is and what it means and why it happens. But I just want you to be aware of it. Now, I did say there is a third way to introduce resampling. Suppose I had used a box to, this is nuanced, but let's suppose you had 2 different images, and I'm going to, all right, let's say I have this, and I've done an extract structured grid. This is not a good demo, but I'll do it anyway. I do extract structured grid on array of plates. Now, I have this array of plates image right here. I can then use this image. I can get rid of the box altogether. So I have this image. I'm going to turn on its crop box so you can see it. So I have this image right here, array of plates from box 19. At any point, I can resample any other image in my workspace into this image's matrix coordinate system. So it's, for us right now, it's going to be the same as if I just did a extract structured grid. But if you have an SEM micrograph of a small area like this and a light micrograph of a large area like this, and they have a slight rotational offset, if you want to be able to do direct pixel by pixel comparisons, you could resample your low-res image into your high-res image, or vice versa. I can just simply right-click the image, so I could right-click the array of plates and say, modify and transform resample geometry. So this is the third way to resample. The first way is to use the resample option, or the sample item right here. The second way is extract structure grid, and the third way is resample geometry. And in this case, you just pick any ROI, multi-ROI, or any image channel, and you select it here. So I could say array of plates from box 19 and hit OK, and now it's resampled this image. So this is a very, if you're ever doing any correlative imaging and you want to resample the image from one experiment, like light micrograph, into the spatial domain of another experiment like SEM, this is how you would do it. So all of these ideas could really come together in a correlative imaging tutorial. If anyone has some data sets they want to share and use to demonstrate that, I'm happy to get into that and make these, drive home these tools. So I understand this tutorial probably does not feel as practical for most users, but we had to do this for completeness because in some advanced workflows, you really will need to take advantage of this. So let's look at it this. Convert, yes, I talked about convert. Invert, I talked about resample. I talked about cropping and clipping, and I talked about extract structured grid. So I did hit all the topics. I don't think there's anything more for me to talk about and show, and we're already half an hour in, so let's go ahead and get to questions and answers. So we do have some questions and answers. So let's see. We do have a question from the beginning about, let's see. Viola is referring to when you use the define range tool, you always see the red overlay. Can that color change its opacity? Okay. So this is an excellent question, and I do not have an excellent answer. So, but I do want to, I'm not going to ignore the question. The question is, if I am using the interactive thresholding capability of define range. So let's show just the visible. So I've got my, let's say my array of plates image, and I come over here and I turn define range. This is red, and it's a little bit transparent. And the question is, can I change what will be the color of the red and the opacity? I don't think you can, and that's why I don't like answering this question. I wish you could. I think we should add that for Dragonfly 2020.2 for this fall, because there are times when you would like something other than red and to change the opacity. So we should add something over here where you could just toggle the behavior. So we don't have it, but let's see if we can. Let's see if we can get it in the future. All right, next person just wants to say thanks for the effort, and I got some thumbs ups. My pleasure. I'm glad we're giving you something you can do and be productive while you're stuck at home. So thanks for the encouragement. Next question, does non-commercial licensed Dragonfly support remote operations from a client terminal? Are there requirements on the graphics card configuration for remote access? So that's a great question. Dragonfly is not supported for remote access. So there are different tools that people try and use, and they're not tested by our team. They're not supported by our team. And I would have to check the license agreement. I don't think they're permitted by the license. We offer a separate feature called Dragonfly Vis Server, and this is designed for people that want to do remote access. It's really designed for people that want to, instead of, if I've got a team of graduate students and postdocs, instead of building a computer lab with 2 or 3 computers that they all have to fight over and share, the whole idea of Vis Server is you build one system, you throw a bunch of graphics cards in it, a bunch of memory, and then multiple people can connect remotely and all access it and use it at the same time, but it feels like you're using it locally. That is our solution for remote access. But for the people that actually have the resources to buy those big computers, we would like them to be paying for the software, so that's not available for free. So that's for people that have budgets for those big hardware solutions. So if you want to use it remotely from home while you're stuck home under coronavirus crisis, email sales at theobjects.com to see if we can make some sort of exception to help you. But we won't be able to give you very much help because we've not tested any of those remote access solutions. But we might be able to permit you to do it on a limited time basis. So I'm sorry, that's an unfortunate answer, but that's what Dragonfly is permitted under the licensing. Next question, I think that question has already been answered. Next question, this is going back to, can we use cylinder shape to extract structured grid? I answered that question at the top of the hour. Next question, is it correct to say for 2D images, for that the working distance value should be put for z-axis and pixel size for z and y-axis? No. So working distance, as I understand it, I'm not an SEM microscopist, working distance should be the value between the pole piece or the detector and the sample. So that's telling you how far it is away, and that doesn't tell you the pixel size for Z. So if I am 10 meters away from my subject and I take a picture with a camera, you don't know from that distance does not tell you how big the pixels are because I may be using a magnification or a telephoto lens. So it's a complicated question, but the short answer is no, the working distance is not a z-axis. If you have there is no z-axis in a 2D image. There is no z pixel size in a 2D image. You're only imaging surface effects. If you want, you can ask me that question offline and I can give you some more detail. Next question. Is there a profile option to see all the intensities along a line or contour? Well, that's a great question. We've not answered it because we never had any tutorial. Well, let me just answer it now. We've never had any tutorial on the annotate tools. So I'm going to turn off define range. I'm going to go to the main tab, and where is annotations? Oh, right here at the top. Here is a ruler. If I were to draw a ruler across my image, now I have a ruler object. Maybe we did answer this, maybe not, I'm not sure. If I have a ruler object, on its property panel is a profile intensity button. When I click that button, it will show me a profile intensity. Now I've got lots of images in my workspace, so I need to tell it which one I want to do the intensity profile on. So I am going to click advanced, and I'm going to say I want the intensity on the array of plates. So I'm going to turn off the intensity on everything else except the array of plates, and here we are. So we're seeing how the intensity changes over the course of that ruler. We can increase the sampling. So let's try 300 sample points. And this is, we're not going to get into all the details of this, but you can have multiple images. So you can have high resolution and low resolution sampling at the same time. But this is how you do that intensity profiling. All right. Next question. Can we select what the interpolation type is in the rotation? What is the default? So no, you can't. We should add it. If you send me an email, I might just put a note in our requirements database so that it gets added, because it's an hour task for someone to add it. When you use extract structured grid, you have a shape, like, I've got a shape, and I just show me the shape. I have a shape and I do extract structured grid, and it pops up this menu right here, and all I do is choose the shape. We should add somewhere here interpolation behavior or interpolation kernel. It's not there, so you can't do it. If you happen to be using the sample tool, so if you do modify and transform and choose sample, you will see here on the dataset tools dataset sampler, you will see sampling. You can choose tricubic, trilinear, or nearest neighbor. Nearest neighbor, we didn't look at today. That will not introduce this interpolation, but you will get sort of the wrong shape. I can't get into that in a short answer, but you can experiment and see for yourself the different answers. Okay, my question disappeared. Next question, how do you correct the pixel size if you typed it incorrect from the start? So actually I showed this a few minutes ago. If you right-click the image channel, you can go to dataset properties, and then on dataset properties, you can just type in the pixel size right here. So that answers that question. Next question, can we select the interpolation? Oh, that's the question I just answered. Let's try and do 2 more questions, then we gotta call it a day. Does it reduce the loss of details if you upsample an image before you regrid it with rotation? Now that's an insightful question. The answer is yes. You can upsample an image before you apply a rotation, and then you will have a more precise, a higher fidelity copy of the image. You will still have interpolation, but the interpolation will now be on over a smaller extent of pixels. So don't have time to do any examples. You could try it for yourself. It's going to take more compute power if you're resampling an image that's already large to a higher density grid or higher resolution grid. So it's going to take a lot of memory and some compute time, but you will get a higher fidelity copy of the rotated images. Let me answer one more question. I don't think these questions show up in order, so I think it doesn't benefit the people that ask them in order. I'll see if I can fix that tomorrow. The last question I'll take is regarding image stack alignments. I've got a FIBSEM serial section that I can share. Does it need to be in a specific format? TIFF would be great, David. If you have a FIBSEM stack of TIFF format and I can use it to demonstrate the alignment tools and I can share it with other people, that'd be great. I think I have your email, so I'll send you information where you can upload the data, or you could share it with Google Drive or Dropbox or something like that. So I will be in touch in about half an hour, and if it's something you can share, that'd be terrific. We'll be able to use it for Friday's lesson. As always, thank you everyone for attending. I hope you learned something new today. We'll get back to more practical applications. I know these topics were kind of arcane for image processing, but again, important and useful. So stay healthy. Thanks for your attention, and see you tomorrow. Bye-bye.